So please, everybody turn on the mic off so that we can begin our class. I'm going to share share Maka, are you ready for the presentation? Are you with us? Ms. Vine?
Yes, I'm here.
Are you ready for the presentation?
No, sir, you can start then. I'll join later.
All right, thank you. So today we are going to continue from where we stopped in the last class. And today the discussion is going to revolve around the survey of human-computer interaction or practices surrounding human-computer interaction. The headings and the subheadings are quite much, so I will try as much as possible to summarize each and every point so that we can go through them all at once. So basically, this chapter or this section is going to focus on the nature of human interaction devices as well as methods. Okay, so this is what today's class is going to be about. Now, let's take a quick recap on what we've discussed previously. I'm sure if you are in the last class, you should be able to know that, or you should be able to remember that human-computer interaction is the study of how people interact with computers as well as other digital devices in a very friendly manner. This is the essence of human-computer interaction. And if you can recall, we say that it focuses on how we can design systems that are easy to learn, easy to use, sufficient to use, safe, accessible, and satisfying. This is the major principles of human-computer interaction. And as we can see on the note, a typical computer system interaction is carried out through input devices such as the screen or monitor, as we know it, the keyboards, the mouse, as well as the trackpad. Now, if somebody is following, I think I made a mistake, or perhaps maybe it's not a mistake, but as I'm mentioning these input devices, one of them popped up, and it is called screen or monitor. Now, 4 or 5 years back, well, let me say 10 years back, if you can all recall, screen was never part of input devices. Do you agree with me or not? Anybody?
Drag it to 6.
Are you with me? Are you with me, class?
Yes, sir. Yes, sir, we're with you.
Yes, sir.
I'm saying that 10 years ago, we never consider a screen or a monitor as part of input devices, right or wrong?
Correct. Right.
Now, what has changed now? Let me throw the question back to you. What has changed now? Why do we have screen as type of input devices? Anybody?
Keep quiet. Please keep quiet.
By the way,
Please
this
keep
session
quiet.
is being recorded. Please turn off your mic. This session is being recorded. Please turn off your mics. Now, my question still stands. Why do we have screen and monitor as input devices? Any attempt, any answer? Obviously not. The reason we have screen...
So can I give an attempt?
Yes, sure, go ahead.
Look at it now.
Okay, so basically, I think the reason why we can add screen as part of input device is because of the modern phones, like modern smartphones, and maybe because of voice and because of voice and speech.
Guys, are we together? Are we together?
We can hear you.
Yes, sir, we can
Okay,
hear
maybe
you.
her line is down, right? Is it me or is her?
I think our network is bad.
Okay, so what I'm trying to say is that screen and monitor were once considered as output devices because we only use them as our secondary method for displaying information. But today we see them appearing as input devices. And the reason is because today we are in the age of touch screen. Most of the phones we use today are touch screen. Even the laptops we use today are touch screen. And sometimes even the tablets as well as our pads, PDAs, they are all considered touch screen. So for that reason, when you touch a screen, it now serves two functions. The first function is the function of an output device, while the second function is the function of an input device. We're using the same object, we're using the same technology to send information through the screen, and we are receiving the information through the same screen. So this is what this particular study session is going to focus on. We're going to look at these different devices, such as keyboards, mouse, trackballs, and so on, in order to create a correlation between their use as well as human-computer interaction. So we believe that at the end of this study, we should be able to have the following outcomes. Number one, we need to understand handwriting and speech recognition. Number two, we need to identify positioning, printing, and drawing devices. And then, of course, we need to explain the different type of display devices that we have. And then again, we need to recognize physical controls as well as sensors. Then number five, we need to differentiate between printers and scanners. And then lastly, we need to explain memory as well as storage format. So this is going to be the outcome, or perhaps we can say what we are going to benefit from today's class. So we'll just go ahead and start with an overview. So as we all know, by the way, I will not be reading verbatim like the way we used to do, because this is so much. If we are to read this thing from the beginning to the end of the session, probably we'll spend like 3 hours doing the same thing again and again. So we are going to simply pick up those important components of the particular session and then explain them in a way that you will understand and in a way that will be more comprehensive to you. So as you know, a computer system, everybody knows this fact. We can't deny it. As we all know, a computer system consists of hardware as well as software. And these components are actually working together. Now, when we have these components put together, that is where we have the idea of input processing devices. Sorry, that's why we have the idea of input, then processing, then output, then storage, and so on and so forth. I'm very sure this is something we learned even in our secondary school, because they taught you that when you have a certain information, we input information, and that information is now being processed. After being processed, it now becomes an output. Now, after output, we then have to store it into a particular kind of system. So if we look at this system, they are also characterized by different types of devices, such as output devices that are used for the display as well as for the printing of the processed data. And these screens, these are what we actually use as our last point of communication. And then, of course, we have the printers as well as we have printers. Now today we even have printers that are 3D in nature, printers that can actually create something physically rather than just seeing it on a sheet of paper. And then, of course, when we do all this processing as well as outputting this information, we have to store it. And these storage systems are divided into so many forms. We have what we call the volatile as well as non-volatile memory. And when we talk about a volatile memory, we're talking about a type of memory we call random access memory, which allow the system to use it as a processing unit in order to solve problems or in order to process information. And then that information is being sent to the to the screen, or probably to whatever component of the system we wish them to be found in. And then at last, we save it in what we call the non-volatile memory. And what is the non-volatile memory? That is your personal storage, where we store our data permanently. Now, the difference between an random access memory and a permanent storage is that a random access memory only saves information within a very short period of time. And this is why we consider it as volatile. Anything that you hear the word volatile being ascribed to it, it means that volatile is anything that does not hold something for a very long time. So a random access memory is a volatile memory that doesn't hold data for a very long time. Sometimes when you shut down the system or when you turn off the phone, automatically this information gets erased from the system. But in the case of a permanent storage, this is what you call your hard disk, and your hard disk sometimes can be actually used for storing data permanently. And this data stays there for a very, very long time. Now, that is that for now. Now, let's talk about another important aspect, which is text entry devices. Now, remember, all our discussion today is going to focus on these devices that help interaction between humans and computers. And at this point, we're talking about text entry devices. Now, text entry devices allow users to enter letters, numbers, as well as symbols into the system. Today, text entry devices are even so advanced that we can even record our information and then the system translates it into text. So that we are going to look into that in a few moments. Now, when talking about entry devices, we cannot talk about entry devices without talking about the keyboards. Keyboard is the first component of text entry device. Now, this keyboard sometimes they come in different forms, they come in different layouts. We have the QWERTY keyboards, we have the normal keyboards, which are not the QWERTY on. We have several types of keyboards. We have the numerical keyboards only. Those are keyboards that actually come only with numerical pads. Okay, so that is that. Now, one thing about the keyboard is that even the keyboard itself comes with so many sections. For example, we have the alphabet keys, we have the number keys, we have the function keys, we have the navigation keys, we have the numeric keys. Now, if you look at the picture here, you notice that at some point, we have some area that constitute only the alphabets. Well, that is where we have the QWERTY. Then we also have the area where it constitutes only the numbers. And then, of course, we also have another area we call the function key areas. All those are keys that come in form of F1, F2, F3, F4, 5, 6, 7, up to 10. Then we also have the navigation keys. What are the navigation keys? These are the keys we use to go up or to go down or to go left or to go right. These are your navigation keys. And then, of course, we have the numerical pad, a particular section kept on one side, especially if the keyboard is large or if the keyboard is long. We have that kind of section where you see only numbers in a kind of pad. Now, this is also another type of keyboard, but these keyboards are definitely not the type of keyboards we use today, but they used to exist in the past. Now, another type of keyboard is your phone pad. Now, this is the type of keyboard we used to use in those days, around 2001, 2002. If you were smart enough to own a mobile phone, I think I got my first mobile phone somewhere in 2003. That was the first time I got my first phone, and my first phone was Samsung R220. That was the first phone I had, and even the SIM card itself, I can recall I bought it for around 60-something thousand naira. The phone itself was around 80,000 naira at that time. That is R220 for you then. It was one of the best phones during that time. And for you to own that phone, you must be somebody or son of somebody or a very big business person. That was how beautiful it was actually. Now, moving forward, if we look at the next type of keyboard, we have another type of keyboard that looks very much like a telephone keyboard, which we used to use in those days on our telephone phones when there was no handsets. We could only use what we call landlines. So these are the type of keyboards that were in use during that time. Now, another type of input device that is very crucial at this point is the one under handwriting, speech recognition, and other type of devices. Now, let's talk about the handwriting recognition. Now, when talking about handwriting recognition, is one of the initiatives that improve human-computer interaction in writing recognition. Today, we have artificial intelligence devices. We have artificial intelligence models that recognize handwritten information. For example, I can write something on a sheet of paper. I can take a snap of that handwriting, and trust me, it will be able to read and capture that information correctly and then write it in a digital form. We also have the speech recognition. Now, the speech recognition is another feature that has been added to our communication system, to our input devices. Now, if I want to type and I'm tired and I don't have the time to type, all I have to do is to use the recognition system to kind of speak out the information. Some of you who are already using ChatGPT, I'm very sure you are acquainted with the function of ChatGPT that supports voice recognition. And we see that today on our mobile phones, on our laptops, and so many devices. Now, another important device is your positioning, pointing, and drawing devices. Now, when we talk about positioning and pointing devices, we are actually talking about those devices that help us in pointing or in positioning something on a particular area or in a particular system. Now, according to the note, mouse is one of those pointing systems. Mouse, as we all know, is a very small device that is movable. You can move it from one place to another. It can go up or down or left and right. It has a ball in the center. That is the time when it was having ball. But these days, we no longer have mouse that support balls. Rather, they use what we call laser light. There's a red laser light under the mouse, which helps in navigating or which helps in controlling the movement of the mouse. Now, this mouse can help in clicking, sometimes double clicking, and sometimes even dragging, or sometimes dropping. We can drag, we can drop, we can scroll. We can actually do a lot of things. Now, this light that I told you about is what we call the optic light. This optic light is the one that now determines the direction. Before, it used to be a ball, but it is no longer considered a ball, but rather a kind of optic light that supports the movement. Now, the next one is your trackball. Trackball, I don't know if we have the image here, but a trackball it used to be a type of mouse or a type of controller which involves moving the whole device. Sometimes user can rotate that ball so that it can control or it can take side or it can help you navigate from one place to another. We see those kind of things used in video recording studios, or sometimes in a surveillance monitoring room where you see somebody with a big mouse and the mouse has a ball. They can be able to scroll the ball so that it can go back or it can go front or it can go, sideways and so on. Now that is what we call a trackball. Now another type of device is under what we call a joystick. Now a joystick is another complicated device that used to serve as a controller in those days. Some of you who have used video games 10, 15 years ago, I'm very sure you're familiar with joysticks, because with a joystick, you can be able to control a game, you can be able to press, you can be able to go up and down and so on. Now, today, people might think that the era of joysticks are over, but trust me, it is not over, because till date, people are using joysticks to manage drones or to manage submarines or to manage things that need control. So they are still active because they are considered to be very light, they are lightweight, and they don't consume so much power. That has given them a very unique advantage over other types of controlling devices. Then we also have what we call the touchpad devices. Now, touchpad devices are the same devices that we use today on our mobile phones, which allow you to touch a particular screen or environment and then produce a very sensitive reaction that can trigger movement or that can trigger action on a device, especially handheld devices or sometimes even mobile devices. And when I say mobile devices, I'm not referring to your phone. I'm referring to any type of device that moves from one place to another. Those are what we call the notepad. Now, the next type of thing we'll be looking at is probably what we call the, let me see, is the tablet actually. Now, tablets, as we all know, these are surface computers, or these are surface handheld computers that are mini in nature. They are not as big as laptops, but they can help you in viewing information in a surface environment or in a far better resolution than a normal handheld device such as the phone. They are very, very good. So actually, I can say for sure that this type of devices are now common and people use them everywhere and any place. Now, the next thing we'll be talking about under these input devices is the display devices. Now, we cannot talk about display devices without looking at their different types. Display devices are categorized in modern technology into two. We have what we call the CTR, which is the cathode ray tubes, and we have what we call the liquid crystal display. Now, let me see if you can remember the difference between these two. Now, somebody is talking, please shut down your voice, turn off your device, please, because we are recording. Your interference can affect the recording, please. Now, when we are talking about devices, let me see if you can quickly remember. Do you know that 10, 15 years ago, when you buy a TV, a television used to come with something that protrudes to the back, as if it has a bottom or some buttocks, right? As if it has a buttocks. Do you remember those days when our TVs used to be very huge? One person could not even carry a TV because of the size. But today we are having TVs that are flat. They are flat. So those type of TVs or those type of displays that used to have the long back, they are what we call the CTR screens, because they have one kind of tube. It's a red tube that constitutes the light. In fact, we even call it gamma light, or sometimes we call it what do you call it? This light in the sun. Oh my God, I forgot the word.
UV ray.
Can somebody tell us what is the light that comes from the sun? Radiation. Thank you very much. I remember radiation. Yeah, so they emit something that feels like radiation, and through that tube they kind of process the light and then bring it out into a resolution where we are able to view the information on the TV. But then with modern technology, with the advent of technology, we now have what we call the LCD, which is the liquid crystal display. Now, these are the kind of display we see today on our laptops. When you place your finger on it and touch, you feel as if there is water inside. So this is why we call it liquid crystal display, because it has that watery feature which allows it to look like a crystal from the inside. Now, what is the disadvantage and disadvantage of these two? I think in modern science, we all agree that the CTR, they emit a very serious radiation which can cause cancer. But with the advent of LCD, we now have screens that emit very small amount of radiation, even though there is radiation, but that crystal display is actually absorbing the radiation before displaying it on the screen. So it reduces the risk of taking cancer in any situation. Now, when we look at these two technologies, all the flat screen televisions fall under the category of the liquid crystal displays. And today, we thank God, we don't even have a sample of what a CTR TV looks like. Moving forward. Now, when moving forward, we need to understand there are certain characteristics of these display systems. Now, the screen contains a vast number of color dots, and these color dots that you see on our screen, this is what we call the resolution. Now, in trying to understand how display works, one needs to understand different components of the TV or of the display. For example, we have the resolution, which is the dot you see on the TV. Sometimes when you turn on the TV using the, what do you call it? The VD, is it VDA you call it? Yeah, I think it's VDA or VDI. Sorry, it's VDI. Now, when you turn on a TV under the VDI mode, you see something that looks like dots, like millions of dots on the screen. Those dots are known as resolutions. And those resolutions, when we put them together, they constitute what we call pixels. And now those pixels, when put all together, they have what we call an image on your screen. So when talking about this, these characteristics, we also have what we call the aspect ratio, which serves as the ratio between the width and height of a particular display. All displays, all televisions, all TVs have all sorts of aspect ratio. Some of them, they have wider ones, some have shorter ones. Then we also have the color depth, which expresses the nature of the color on that particular screen. And even the color themselves, some devices have more color depth than other devices. So if you have time, I'm very sure you should be able to read through this and you will get a lot of hint inside this information. Now let's move to the next thing. Just give me a second. All right. Now, the next thing we are talking about is the print technology. Now, when talking about the print technology, from the word as it implies, we all know that print technology provides us with printed information on a given paper or on a given surface. I won't say paper because some printing these days is not only constricted, it's not only limited to printing something on a sheet of paper. It means that nowadays we can print on the wall using a machine. We can use a printing machine or a printer to print on clothes. We print on materials and so many things. Okay. Now this printing is being carried out by millions, if not billions, of dots on the printer, and these dots, they are what give rise to the resolution as well as the image that we see on a particular paper as we print it. And we all know that each printer uses what we call an ink, and even the ink themselves, they come in so many different forms. We have the inks, we have the toners. The inks are perhaps the olden way of, or the olden type of printing material. And then of course we have the toner, which is more like a powder. It's a powder you add to a printer and then it prints on that particular device. That is it. So let's keep the font, the pitch. Let's look at, okay, now let's talk about the font a little bit. When we're talking about font, we're actually talking about the style of writing that we use during printing. And this is not a new thing to you. I'm very sure everybody here is familiar with all different types of writing styles and format. We have the famous one, which is the Time Roman. We have the Arial, and we have the Sans. These are all some of the oldest types of writing or fonts. We also have the uppercase, we have the lowercase fonts, and then we have what we call there are all sorts of writing styles. They all come in different curves as well as lines, different styles, and so on and so forth. Now, the next thing we'll be talking about is the scanner. Scanner is also another important component as far as input device is concerned. As we all know, scanners are devices that when we add papers or when we add images, we can actually transform those images into digital format. If supposing you have a paper, something written on a paper, and you want to translate it or you want to convert it into a digital form so that you can read it on a system, we use scanners to achieve that. Now, even the scanners, there are of 2 or 3 types. We have what we call the flatbed. They are placed on glass or sometimes on a surface. We have the handheld scanners. These are scanners that we use to scan things as we are moving the scanner on our hands. The scanner is also taking note of whatever it is that we are using. The next is what we call the ORC, that is the optical character recognition. This is another component of the scanner, although not a physical component, but a software component, something we don't see, but we feel. Before the coming of AI, it was very difficult to kind of scan a handwritten information and then print it on the system. But with this optical character recognition, we can write something in a very clear handwriting, place it on top of the scanner, activate the ORC, and then the ORC will convert it into digital copy. And now we can have it on a system. We can even edit it. We can even copy it. We can even change 1 or 2 things in terms of the style and so on. Now, what is Xerox? Xerox is a name we give to photocopiers. I believe you all know what a photocopier is. A photocopier is a machine that allows you to make a replication of a particular information that you have on a sheet of paper. So when you put a paper into a machine and then create a replica of that machine, we actually perform Xerox. Now, if you go to the Western world, if you like, go and spend the whole day asking somebody, please show me the photocopy shop. Nobody knows what a photocopy is. Photocopy is a Nigerian English. If you go to other countries in the Asia, in Europe and America, they all call it Xerox. So if you are looking for a photocopy shop, tell them I need a Xerox. That is where they take you to. Now, the next thing we'll be talking about is the idea of memory. Now, when we are talking about memory, although I've just mentioned memory just a few minutes ago, and we mentioned that memories come in 2 ways or 2 forms. We have the volatile memory as well as the non-volatile memory. And they are also considered as short-term memory as well as long-term memory. So a memory, as we all know, is a temporary storage that stores information that is needed by the CPU. When the central processing unit wants to process something, for example, you open a calculator on your laptop and you want the calculator to calculate 10 plus 10. So the moment you hit 10 plus 10, it takes the arithmetic operation into the random access memory where it is now given a space so that it can now be able to compute the information and give the answer. Now, it is the same thing as saying that we have a group of footballers who want to play football. They are not playing in a stadium. They only want to go and play, and after the game, they all want to go home. So they just hire a studio, a space in a studio. Sorry, not studio, stadium, okay? In a stadium. They hire a space in a stadium. As we know, these days, there are a lot of sports centers where people hire to play football. That space you hire to play football temporarily is your short-term memory, because you are only going to use it for a very short time in order to play football. After you play the football, you leave the court and you come back another time. So this is exactly the work of a short-time storage memory. This storage memory, they come in various sizes. They come in different series. We have the DDR1, the DDR2, DDR3, DDR4, and I think they have DDR5 now. So they come in so many formats and in so many sizes. Some are 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, 32 GB, and so on and so forth. This is in the format in which they come. Then comes the long-term memory. And your long-term memory is your hard disk, the hard disk that we use, whether it is external hard disk or it is internal hard disk. And these hard disks are also divided according to their sizes. Some are even divided according to the nature of operation they do. We have what we call a RAID. RAID is a special type of hard disk which creates a scenario that allow you to be saving data in a mirror setting. When I say a mirror setting, I mean that anything that you put on one partition of that hard disk, automatically it creates a copy or a replica of that data into the mirror. So in the end, if one component or if one side of the hard disk is damaged, the other side will quickly help restore that damaged information so that the data will not be completely lost. So therefore, we have all sorts of long-term memories in form of hard disk, and they come in various sizes. They also come in DVDs. They also come in Blu-rays. Blu-ray is a special type of DVD that has more space, more memory space than the average DVD. There are all sorts of these memories. Then we also have another type of memory we call the virtual memory. Now, what is a virtual memory? A virtual memory actually is a memory that does not exist physically, okay? Sometimes when we have a system that uses a virtual memory, it means that the system is probably engaging in a simulation test. So that environment is only created temporarily, pending to when that simulation is completed. As soon as our simulation is completed, we turn off or we delete that virtual memory. Again, sometimes if your system is not running very fast, or your system is slow, we create what we call a virtual RAM, okay, VRAM. We create a VRAM. Now, this virtual RAM is created from the main hard disk of your system, so that if your system is having a normal 4 GB RAM as the size of your RAM, then by adding a virtual RAM, you can add up to 16 GB, up to 32 GB, all from your hard disk. Now your computer will be behaving as if that virtual RAM is also a physical RAM, part of the system, as if the system, as if the memory and the virtual memory are actually the same physical entities, when in reality, they are actually not. Now, the next thing we'll be talking about is still under virtual memory, and it is known as compression. And compression is a system or process of reducing the amount of storage required in order to save or store something on a memory space. Now, sometimes, if you are traveling abroad, if some of you have traveled abroad, you know what I'm talking about. For me, I've been to many countries in the last 10, 15 years. So whenever we want to travel and we have a lot of goods, when you pack up your bag, there is a lot of space for air. Air consumes majority of the space. If you are to use a machine to compress the air and to extract the air out of the box, you realize that the size as well as the weight of that box has reduced significantly. That is what we call compression. So when you compress data, it is actually saved in a more appropriate space without consuming so much of space from your drive. Now, even this conversion from normal size to compressed size, it comes with its own advantage and disadvantage. The disadvantage is that it reduces the quality of that document or of that file. Probably some aspect of the file will be reduced or will be lost. Maybe if this is a photo, you realize that a photo of 5 MB that has been reduced using compression is no longer 5 MB, but rather it is 3 MB. But when you open the photo, you realize it has lost its quality. It has lost its quality. It is no longer as qualitative as it was before the compression took place. Now, the next idea is about storage format. Storage format explains how information is being stored on a machine. Now, initially, if we trace the history of storage as well as the history of computing, you realize that files have been stored in so many formats and in so many ways in the past. The first example I like to give you is what we call the ASCII. The ASCII is a format of storage that we use when storing text. But during those days, this is a bit binary code that represents letters and characters. So what we have is that this type of writing format or text format, when you open it, it's probably not readable by you. Human beings hardly read any information stored in ASCII because normally it is saved in a binary code. And the moment you hear the word binary, it means it constitutes millions of ones and zeros. Anything that comes in binary constitutes hundreds of thousands and millions of binary numbers. Until after you convert it to normal letters, that is when you find it sensible enough to read and understand. We also have the UTF version 8, which also constitutes an 8-bit encoding of a 16-bit character set. This is also another encoding process. They are all in use in those days, but today we no longer apply them in real problems. Their application has now been reduced because we have a lot of cryptographic technology at large solving the problems they were able to solve, since most of them are used for encryption and for disguise when we don't want something to be easily readable or easily accessible. So we use this kind of formats. Another important format is what we call the XML, which is the extended markup language. This is a language used by most databases as well as our web applications. We also have other storage formats which exist on images, such as the GIFF, the JPEG, the TIFF, the PICT. These are the formats of images that we use till date. Some of them are better than others. Some of them are, weaker than the others. In terms of video, we have the MPEG and we have the WAV. Okay, these are also files that we use during creating media files, especially the video media files. Please let me take a sip of water. Now, the next topic we'll be talking about is processing and network interaction.
Hello, sir. Please, can I ask a question?
Yes, go ahead.
Okay, thank you very much. My hand has been up since. Good evening, sir.
Oh, I didn't see. When I'm presenting,
okay, so
it's only you guys that can see what is happening there, but I'm more concerned about the screen here.
Yeah. Okay, so quick one. Sorry, I didn't want you to go too far before I have to bring us back. So it is regarding the memory that we the concept of the RAM and the sizes that they come there with. Okay, so now my question is, I have a system, right, that consists of a 8 gig GB, and within time of usage, I discovered that the system is lagging, and then based on analysis, I am based on analysis and troubleshooting, I'm required to add to that RAM probably additional 16 if the system, of course, can take about 32 GB. Now, the question that I really want to ask there is if my RAM is serving as a short-term memory, which means that whatever I'm processing at the moment is what is responsible for keeping that information together for me to process it at that time before finally dishing it out to the SDD or HDD for proper storage. Why does it lack? It is not being consumed. So how come I'm running out of speed I'm supposed to have using that 8 GB?
Okay.
GB, yeah.
So before I answer your question, I like to ask you a question too. What is the architecture of your processor? What kind of processor is it? Is it which core is it? Are you with me?
Sorry. Yeah.
Are
I'm
you
with
with me?
you. You said?
Yes. Which core is your
Yes, please. I'm
processor
with
now?
you.
Which core is your processor at the moment?
Which is my pro?
Which core?
Okay.
Which core? Is it a core i7, a core i5, a core i3? What core is it?
Is i5. Is a core i5.
All right.
i5. Either way,
All
either
right.
i5 or i7. I'm just asking a general question, but my system is i5.
All right. So in some situations, there is no a definite answer to this question. Now, this is a troubleshooting problem that requires a step-by-step analysis in order to understand what the problem is. Now, let's have some scenario. The first scenario is that probably your RAM is weakened. When I say it's weakened, sometimes after a very long time of use, you realize that a component has become weak. So probably your RAM is becoming weak. There has been erasing, adding, erasing, adding, erasing for a very long time. And now the pallets of the heart of the memory are kind of, degrading, okay, degrading. So if that degradation is taking place, it means that it's not that the RAM is no longer useful, but perhaps we can say that the RAM is indicating to you that I think it is time for you to change me because I'm tired. That is one possible scenario. Another possible scenario is that, you see, sometimes our computers are so complex that we have installed so many applications, we have installed so many software. Now, most of the software we use, they work in background. What do I mean by they work in background? They work in background in the sense that they work and we do not see how they work. They work and we do not see they are working because they are working in the background. For example, one application is being supported by another application is being supported by one service or the other. Now you realize that these services are running in background, these applications are running in background. So it sometimes they consume power, they consume memory. So when some kind of important task comes into the memory, rather than the memory to focus on solving that particular task, those other things that are running in background are also being taken. They're also taking you, they're also using some part of the RAM. So sometimes you have to go and manually, reduce the number of applications that have been processed by your RAM. So this is why in my advice, if your memory is good and you think the memory is not bad, then you should consider the following diagnosis. Number one, probably you have not formatted the system for a year or two. And naturally, when you are using a system for almost a year, then you should at least format it once in a year. And when I say format, I don't mean remove the original Windows. No, what you should do is do a factory reset. What kind of factory reset? A factory reset that maintains your drive C. It maintains your drive D, so that the only thing that gets erased is the system as well as program files, as well as the memory. But your backup drive, they are all considered safe. You can easily restore your data into your system without taking much of your time. So I'm recommending maybe you should go for that. or secondly, you should go for a replacement. If you cannot go for replacement, then go for addition, because some computers, they come with 2 RAM slots. If there is additional RAM slot, then go for an additional RAM slot. If there is no additional RAM slot, then you should go for a virtual RAM. How do you create a virtual RAM? I cannot precisely remember the steps, but I can tell you that if you go to your computer properties, when you right click on computer, you go to properties. When properties open, I think there is an option under systems. Now, under that system, there is a place where you create something we call virtual space, but I can't really recall exactly the steps. But I know, and I've done this many times, a couple of times. Just go to Google and write how to create a virtual space, or how to use your hard disk to create a virtual memory within your system. They should be able to give you the steps. Probably this could solve your problem. And I hope this has answered your question. The answer is so big. It could be this or it could be that. So precisely, we cannot, anticipate what might have caused this problem for you. I'm sorry about that. So can we proceed? Can we proceed?
Yes, sir. We can hear you. You can go on.
Yes, please. Thank you very much for that.
All right.
Thank
All
you.
right. So we're talking about processing and networks interaction. When we're talking about processing and network interaction, we're actually talking about how information is being executed, or how instructions are being executed. And then, of course, how network plays a role in the interaction. Okay. So based on the note, it starts by saying that there is a finite speed application applicable to processing, which is also governed by the Moore's law. Now, who is Moore? Moore is a person, is a researcher, and we are going to see a lot of his principles as well as models being read in these sections. So there are also limits of interaction, both in single users and network computing. Now, what this is trying to say is that when you have a system, there's a difference between a system that has just a single user and then a system that has multiple users. Now, when we say networked computing, it means not one, not two, not three, several devices and several users are actually connected to this system. Now, what the law says, what Moore's law says. Now, the Moore's law observes that computers get faster and faster. Okay. Now, in 1965, Moore and Moore, that is the co-founder of Intel, noticed a pattern that processor speed double every 18 months. Now, you see, this will answer my question. We have just answered now. I told you sometime with time, the demand increases. The demand increases. Why does the demand increase? Because new software are introduced every day, and with the introduction of new software, they demand more space. And sometimes these new technological advancements, they come with spatial requirements. So this is why Moore says that this pattern of increase or this pattern of increment in the processor speed, sometimes it indicates to you that something new has come into the system. Now, let's move forward. Now, in moving forward, we talk about another important aspect, which is the history of network. Now, network actually started far as 1969, just a year before, just 9 years after Nigeria got its independence. Now, in this context, we learned that a particular department within the U.S. department, that is the department they call DAPANET, okay? That is the department. This is a department under the Department of Justice, under the Department of Defense. They had a situation that demanded that troops who were sent abroad should be able to communicate with the U.S. Department of Defense. So that was what gave rise to the technological innovation of network. And that network gave birth to what we call the TCP/IP, that is Transmission Control Protocol, as well as Internet Protocol. These are two fundamental protocols that were introduced somewhere in the 1960s in order to address the issue of communication by the US military. And this TCP/IP, they are the fundamental or the foundation of communication in those days before we could have what today we call the OSI model. And the OSI model is a little bit more advanced in terms of connecting networks together as compared to the TCP. The TCP is constituted of only 4 layers, only 4 layers of network. That is the application layer, the network layer, the transport layer, and the physical layer. But when you look at the OSI model is constituted of about 7 layers, starting with the physical layer, down to the session layer, down to the data link layer, the network layer, the data link layer, as well as the physical layer, and so on and so forth. So we also learned that email was also part of the project, because with that gave rise to the birth of emails, the emails we use today. And then, of course, the HTTP, which is the hypertext transmission protocol. All these were built together in order to achieve what we call a network today. Now, what are the benefits of network in the 1960s? The benefit number one is file sharing. Files were being exchanged between troops or between military officers at the war zones and then the Department of Defense. Another thing is through printing sharing. Now, print sharing is something that has been in existence for a very long time. A scenario where one printer is linked to a system, and then each and every other computer within that environment can actually send a print request into that particular system, and that particular system will facilitate the print. Another thing is internet sharing. With this network, we were able to introduce the internet, and with internet, we're able to create sites using the HTTP as well as the email. And then above all, it facilitates communication. And then, of course, today, we're in the age of cloud computing, where everything lives on the cloud. Our infrastructure is on the cloud, our memory is on the cloud, our services are in the cloud. Basically, everything now can be considered part of the cloud system. So these are the benefits of network. And then, of course, we have the challenges of the network as well, because nothing has advantage that doesn't have a disadvantage. And the major challenges of the network in those days, even today, is the security threats. A lot of networks are facing security threats. Just yesterday, I saw on the news that UBA, is it UBA? Yes, UBA, right? Yeah, I think. They were hacked, and millions of naira were taken out of their bank because of the cyber attack. And then, of course, there is the problem of network congestion. The more the network grows, the more the congestion grows as well. And then we have the problem of hardware failure. Even Facebook is now facing hardware failure these days, which means that nobody is immune from falling into this problem of hardware failure. So in summary, I think all we have discussed today is that we learned that human-computer interaction depends on so many technological devices, which include the input devices. And under the input devices, we have spoken about devices that help you capture user actions, devices that help you process information. We even discussed the memory as well as the data input, output, and then, of course, finally, we talk about networks. And then, all in all, I think the mission of this session, the mission of this study session is helping us understand the technologies that help designers build systems that are efficient, user-friendly, reliable, as well as accessible. So basically, these are all we have discussed today, and the rest are just questions in case we want to go for Q&A. So basically, these are what we have for today. So with this, we come to the end of today's session. So I will now get back to you, and then let's hear if you have any question or something that you would like to contribute. I was hoping that Shiomaka would actually present something for us today, even just for 2-3 minutes. I don't know how prepared you are. If you are prepared, I will be ready to stop sharing my screen so that you can also share your screen. And for your information, I'll be taking attendance. So I will take a screenshot of all the people that attended today's class. And I told you from now on, you should be using your names or your registration numbers when signing in into a session. So Chiomaka, are you ready? So I guess
Yes,
she's not
sir.
ready. So any question? Oh, all right, go ahead. We're listening. So what do you have for us?
Basically, sir, you've touched every aspect of today's lecture.
So no need for you to talk, right?
Not exactly, but then you were able to touch today's aspect, and it was like really detailed. It was like very
Chiamaka, I
interesting.
think you should jump politics. Honestly speaking, you should jump politics. It will suit you. Anyway, thank you so much, Chiamaka, for the good intention. You wanted to present. Thank you very much. So, class, if anybody has a question, please go ahead and ask. The floor is yours. Any question? We had a very lengthy discussion, but we had something more like a summary. We couldn't go through everything, like to read cover to cover. We couldn't do that. That is impossible. To take our time and to consume a lot of energy.
Okay, sir.
Yes, go ahead.
Okay, thank you very much for the tutor once again for the class. Okay, so I want to just get more understanding anyway. So you make mention of creating having to create a virtual or is it a virtual space in the physical place, how
Virtual
that
memory.
a kind of a simple virtual memory that it is synced with the physical memory and then work as one device, one physical device in the system. So I don't know whether I kind of get the point, but I was wondering if there is more details, like how, because I've actually haven't experienced that, haven't experienced the creation of the virtual memory syncing together with the physical memory and all of that. So it kind of came to me as new, and I would love to, if it is okay, to get a little bit understanding as regarding that.
Okay. So basically, what we are trying to say, I'm thinking of a good example that I can give you. You see, in the body we have the heart. The function of the heart is to circulate blood from all different components of the body, the brain, the intestines, the muscles, the kidneys, and so on and so forth. Now, when the heart is tired and something is wrong with it, it can no longer function fully. What do? We go for surgery. We do what we call a bypass. Now, that bypass is a kind of way we create a channel that allows the heart to function without having to wait for something to be done. Now, you see, that channel that we create was not part of the heart, but rather it was an artificial channel that we create so that the heart can survive. So in a computing setting, sometimes you realize that we have a particular memory, a particular random access memory. And this memory, it has a very limited amount of size. It is not like the non-volatile memory or the long-term memory, which used to come in big sizes, 60 GB, 120 GB, 256 GB, 500 GB, 1 terabyte, 2 terabyte, and so on. The memory does not come in terabytes. It only comes in sometimes GBs, very little amount of GBs. For example, we have memories that are 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, 32 GB, 62 GB, 64 GB, and then 120 GB. These are the common and most advanced memories that we have. Now, time will come when the demand of your system increases. Now, when the demand increases, the system can no longer depend on the random access memory to process the information. Sometimes, in order for the system to work, it has to be kind of freezing. It has to be kind of confused whether to drop this or to drop that in order to have enough space to process certain information. There are software or there are services on the system that require large space. For example, if your memory is just, let me drink water, please. If your memory is 1 GB, and probably the services that run on your system are more than 1 GB, or they require more than 1 GB to work, okay? Maybe let's say each and every one of them require at least 100 MB before they can be able to work. And we have many of them. So you realize that that size of your memory, which is just 1 GB, is not enough to process, requests that constitute more than 1 GB of space. So you realize the system will be slow. Sometimes the system will be hot. Sometimes the system will be misbehaving. It's because there is no breathing space. The system wants to breathe, there's no breathing space. We need to create additional space. And we cannot add additional space using a physical memory, meaning we cannot purchase a physical memory. We don't have the money to do so. Now, the inventors of computer, they now introduce what we call the virtual memory or the virtual RAM. Now, how do they do it? They now say, okay, if your RAM is just 1 GB and you have a hard disk that has a size of, for example, 1 terabyte, take a portion of that 1 terabyte, for example, take 32 GB out of it, convert it into a virtual memory. As soon as you do so, the system will start recognizing that virtual memory as if it were a physical memory, because it is all a matter of programming. You have already executed the request, the system has already launched it, so a portion of your physical memory is now taken and added to the physical memory. Remember, we are using a physical memory to create a virtual memory. So literally, we are cutting something out of the physical memory to turn it virtual so that the memory can recognize it or the memory can work with it as if they are now a whole. So if you have 1 GB and then you have another 32 GB of virtual memory, we now have 33 GB of memory working together. According to the system, they are just one. They work alongside each other. Now, when you have tasks that require at least 10 GB of space, all of them will be fed into the space, because now the system is behaving as if those sizes or those spaces are all working together as a single entity. I hope this explanation will make you understand. Thank you for the question.
Wow, thank you very much for that. Thank you
You're
so
welcome.
much, sir.
Any other question before we go?
Yes, sir. I want clarification on something, sir.
Yes, go ahead, please.
Okay, sir. Sorry, sir. Regarding when you mentioned Xerox, so my view was that Xerox is part of a company that produces photocopier. But you said when you mentioned Xerox, that means photocopier. Is it that they're the one that manufacture photocopier or what? I don't know if you can throw more light on that.
Let me think of an example of something that was treated in the same way. Let me see. You know, good example. You know, in the past few years, when you pick a pen to write, we used to call it biro. Can you borrow me your biro? Right or wrong? We used to have what we call a biro. So you see, Biro was actually the company that manufactured a pen. But because people at that time were more interested in calling Biro, so now people turn Biro into Biro by force. So everywhere you go, people call all sorts of pen Biro because people were so much using Biro. Now, let me give you another example with pure water. Now, the first pure water that was introduced in Nigeria was actually called pure water. Pure water was the name of the company, pure water. But then eventually, people started to use pure water to refer to all sorts of water that are considered in pure water format. So with that, the company Xerox became so powerful, so acceptable that people now started calling the process of photocopying as Xerox itself. So this is how the word Xerox emerged into what we call Xerox today in the modern world. But the word Xerox actually is a brand name turned into a generic or a nomenclature name or something called photocopier. But in some part of the world, we don't call it photocopier. Travel to India, tell them photocopier, nobody will listen to you unless you say Xerox. I hope that answers your question.
Yes, it does. Thank you, sir.
All right. Any other question before we go? So I'm going to take attendance. Now I think we have only 20 people in attendance. So I'm going to take a screenshot of this class. And please tell your people that I'm taking attendance every day. And I will try as much as possible to keep my promise that only people with 70% attendance will be able to take my exam by God's grace, unless if somebody overpower me. Yes. So in the absence of questions, if there are no more questions, we'll take a leave and then we'll see again next week. And next week, God willing, we'll be talking about the study session number 3 under module number 1. So next class, we'll be talking about the basic component of human-computer interaction. So you can please read ahead so that at least you will not be taken off guard or you will not be surprised with the kind of things we'll be discussing. At least reading before coming to the class will help you understand what we'll be reading in class, God willing. So guys, thank you very much for attending. And I wish you all a good evening. If you permit me, I like to take my leave now.
Thank you so very much, sir.
Okay, sir. Sir, if
Thank you.
class go
Thank you
to
so much, sir.
be on LMS.
Pardon? What did you say? Somebody said something about LMS. What did you say? Hello?
I think it's
Somebody,
about the recorded
somebody
session.
mentioned something about
your record
LMS.
says you're going to be on LMS.
The problem is that the LMS does not support link these days. I don't know why. I don't know whether it is just me or everybody. But whenever I put a link to something, for example, I should be posting this link in the LMS, but unfortunately, it's not taken. So even when I posted the WhatsApp group link, most of you were following me privately to request for it, and I posted it, but it was not showing on your system. So this is the problem I'm facing right now. I don't know whether this problem is peculiar to me alone. Can somebody tell me if it's just me, or is the same thing with others?
So I think
LMS has been down.
because we have other tutor posting
Yes, exactly.
And they're posting links, right?
Yes.
So
Yes, sir.
I will talk to the technical people. We'll see how we can sort the problem out. Thank you very much.
I guess the YouTube, sir. Hello, sir.
Yes, I'm listening.
I guess the YouTube link that you sent, I guess is okay as well.
No, I need to give evidence that I'm taking the classes. Otherwise, somebody will say I've never taken a class for once.
Okay.
You understand the kind of thing. The LMS is there for what we call
Very true.
well, what do you call this? There is this type of audit they do annually. When they check and see that no activity on the LMS, it raises a lot of questions. So this is why it's important to also work with the LMS. Otherwise, they will suspect lack of cooperation at the organizational level. Anyway, we'll sort the problem. We'll try to sort it before Monday. So thank you very much, guys. And we see again next week. Have a good evening.
Thank you, sir.
Thank you, sir. Thank you very much, sir.